Hello, Abhinav. Hello, Abhinav.
Sir.
Okay, Abhinav. Okay.
Sir.
Okay. In the previous class, we discussed which case. We, we want to discuss a minimum spanning tree. Okay. So, what is MST? Okay. So, today we want to discuss MST and the algorithms used for finding minimum spanning tree. Okay. So, uh, which are the algorithms we are using? One is called Prim's algorithm, and another is KRUSKAL algorithm. There are two algorithms that can be used for finding the MST. Okay, so in the previous class we discussed what is MST. Okay, so it is a tree. Okay, so what is meant by a tree? What is a tree and a graph? Okay, tree is an acyclic graph. Okay, tree is basically a graph, but it is acyclic. There should not be any loops or cycles. Okay, okay, so it is a tree. Minimum spanning tree is a tree. What are the properties of a minimum spanning tree? And first about the edges. Okay, uh, edges will be a subset of the edges. Okay, then it connects all vertices in the graph. Okay, the it should include all the vertices. Okay, suppose this is the graph, and the minimum spanning tree should include all the vertices. Okay, that is another property. Okay, it includes all the vertices. It should include all the vertices. Okay, next is next property is there should not be any cycles. Okay, as I told, it is a tree, so there should not be any cycles. Okay, you know what is a cycle. Okay, all right. Next, and the last important property is the sum of the weight of all edges. Okay, the sum of the weight of all edges should be minimum as possible. That is the most important property. Okay, for example, here I am considering the edge weight. This is an edge, and this is the 11 is the weight. Okay, suppose what is the sum of the edge weight is in this case? It is 11 plus 6 plus 6 plus then 8 8 plus, in this case 8 plus, then this also 8. Okay, this also 8 8 plus, then 4 plus 4, so plus 4 plus 5. Okay, so 5. So basically 4 to 6 edges are there. 1 2 3 4 5 6. Okay, there are 6 edges, and this sum of the edges edge weight should be minimum. Okay, and we should visit all vertices. Okay, also all vertices should be included in the tree. Okay, so this is the minimum spanning tree concept. Okay, so I think this definition is enough for understanding the concept of MST. Okay, so this is MST, and then yesterday I told you there are two algorithms. One is Pascal algorithm and another is Prime's algorithm. So we want to study both cases. Okay, so Okay. 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 So today we are going to discuss about the KRUSKAL algorithm. Okay. KRUSKAL algorithm. This is the algorithm. Okay. You can note here. This is the algorithm, and initially there is a set A. Okay. There is a set. There is a variable A, which is basically a set. Okay. So it is initialized to empty. Okay. Next, we will add all vertex. You can note here there is a for loop. Okay. There is a for loop. Okay. This for loop add all vertex into this into A. Okay. Into A. A is initially empty. We will you can note here make set. There is a function make set of V. Okay. Basically, the make set function will add all the vertices to A. Okay. So after that, what we want to do in the fourth step, we want to sort the edges. Okay. Okay. In the fourth step, basically these 1 2 3 are initialization steps. Okay. These 1 2 3 are initialization steps. Okay. Now the fourth step is very important. What is the mean? What we are doing in the fourth step? Sort the edges of G dot E into non-decreasing order by weight W. Okay. That is, we want to sort all the edges in the graph in non-decreasing order. Okay. Okay. Try to understand the meaning. Sort the edges of G dot E. G dot E means the G dot E means number of edges. Sorry, not number of edges. Edges in the graph. Okay. So sort the edges of G dot E into non-decreasing order by weight. That is, we want to sort the edges in the graph based on the weight value. Okay, based on the weight, and we can sort it in the ascending order of the weight. Okay, that is this step C. Okay, that is we want to sort the edges in ascending order of weight. Okay, this is the fourth step. Okay, then we will enter a loop. Okay, in the fifth step we will enter a loop. Okay, so what is fifth step? Fifth step, this is fifth step. Okay, in this step we will enter a loop, and for each edge v do u comma v. Okay, for each edge u comma v, we want to take edges one by one. For each edge u comma v belongs to G dot t taken in non-decreasing order. That is, we should take each edge in non-decreasing order. Okay, means in the uh, least weighted edge at first, then next least weighted, and so on. Okay, so we want to take each edge in the non-decreasing order, then check this condition. Okay, then check this condition, that is, if find set of u not equal to find set of v. We are taking an edge uv. Okay, we are taking an edge uv, that is, we are taking an edge, suppose we are taking an edge uv. Okay, uv, then after taking the edge we should check this condition. Okay, that is, this condition is basically this condition. This condition is basically that there should not be any cycles. Okay, this condition is used to ensure that, you cannot hear, this condition is important. This condition is used to ensure that there should not be any cycles. I told MST should not contain any cycles. Okay. In order to avoid the cycles, we are using this condition. Okay. So find set of U not equal to find set of V. Then if it is not equal, then we will add the edge to the A. Okay, we will add the edge to A. Okay, basically this is a very simple concept. That is, we will take an edge in the non-decreasing order, then check whether that edge form any cycles with our set. If not, that is by using this condition, find set of U not equal to find set of V, then there should, it will not create a cycle. Then we will add that edge to A. Okay, then we will call union function is used to take the union of U and V. Okay, so this is the body of the loop. Okay, so this is the working. I will one more time I will repeat the concept. Basically, initially A is empty. Then we want to take each vertex and create a set V. That is, we will initially add all vertex to A. Then we want to sort the edges into the non-decreasing order by weight. Okay. Then we want to take each edge and check each edge in non-decreasing order. Okay, each edge in non-decreasing order. Then if that edge will not form a cycle, then add it to A. Okay, that's all. This is repeated for all edges. Okay, so now we are moving to this is the algorithm. You should study it for the exams. Okay, this is the algorithm. Now I'm going to the working of that algorithm. So basically this is a very simple algorithm. Okay, it's a very simple algorithm, very simple. Okay, so what we are doing is that I told already told we want to sort the edges in ascending order of their weight. For example, if you consider this graph, then which are the edges in it? One edge is H to G. It is the lowest weighted edge. Okay. Okay. H to G is the lowest weighted edge. So I will order in this way. Okay. 1. Okay. Then second lowest weighted edge is G to F. Okay. G to F. You cannot hear. G to F. This one. This is its weight is 2. Similarly, I to C is there. This weight also 2. Okay. This weight also 2. Anyway, so I am arranging in the ascending order. 1, 2, next 3, 4. In this way, which will be the next one? 4. Fourth one. Now the weight just more than 2. Okay. 2, 3. There is any 3? No. Now 4. Okay. 4 is the next one. So which is C to F. This edge is C to F. C to F. C to F. Okay. And its edge weight is 4. Okay. In this way, I will arrange all the edges in the graph. Okay. I will sort all the edges in the graph. Okay. And there will be how many edges in this graph? There are 1, 2, 3, 4. More than 10 edges. Anyway, I want to sort all the edges in this way. Okay. Initially, A is equal to empty. Okay. Next, what I will do? Very simple concept. I want to take the edge with the minimum weight. That is, I want to take the edges in the ascending order. Okay, first I will take H to G. Okay, then I will add it to A. Okay, so what will happen? Initially A is empty, so I will add H to A. Now H to G is added to A. Okay, and G is added. Okay, very simple concept. Next, what I will do? Second edge I will take. Okay, that is G to F. Okay, so I will add G to F to A. Okay, basically this is A, initially empty. I am adding the edges one by one to this A. Okay, so this is G to F. Okay, here there is no arrow mark. This is undirected. Okay, sorry. Okay, so 1 minute. Okay, so first I will take the edge with weight 1 and which is H to G. Okay, H to G. Next I will take G to F. Okay, G to F. Its weight is 2. Okay, and I will add to A. So this is A basically. Okay, A is initially empty. I am adding the edges one by one. Okay, you can note here H to G. I added. Then I take G and F. G and F will not constitute a cycle. Okay, before adding to A, I should consider that it will not form a cycle. So I will add G to F. Okay, next what I will do? My question is to Devika. Devika. Next what I will do? Devika. Devika. Devika absent or no? Devika absent or no? Okay, Anugrah, question ചോദിക്കുന്ന ഒരു നിങ്ങൾക്ക് സോ പ്ലീസ് റിപ്ലൈ. നിങ്ങൾ ഒരാൾ ആൻസർ പറയുകയാണെങ്കിൽ എനിക്ക് കോൺഫിഡൻസ് വരും. ഓക്കെ, സോ പ്ലീസ് റിപ്ലൈ. അനുഗ്രഹ്, നിതിൻ ബാബു, നിതിൻ ബാബു.
No, no.
നിതിൻ ബാബു.
Hello, sir.
കേൾക്കുന്നുണ്ട്.
നിതിൻ, നെക്സ്റ്റ് വിച്ച് എഡ്ജ് ഐ വിൽ ചൂസ്?
ഗ്രാഫ് കാണിക്കാമോ?
1 minute. Okay, this is the third edge. Okay, third edge. This one is the third edge. Anyway, this is the graph. Okay, so we can go to the graph. So I consider this edge H to G. Then I consider which edge? Okay, in this example you can note here. 1 minute, Nitin Babu. In this case, there are two options. Basically, these two are having the weight 2. G to F is weight is 2. I to C also 2. In that case, arbitrarily I can choose anyone. Okay, so here I selected G to F, but in the text they selected I to C. Okay, so what I will do, going to this example, they selected this path. Okay, I to C. Okay, then add it to the graph, add to the set A. Next, which I will take, Nitin Babu.
Sir, GF, which is our way to.
G to F I will choose. Okay, but before selecting and adding to the graph, we should check what condition. This should not form a cycle in the set. Okay, so here you can note. Okay, Nitin Babu, thanks. Next, H to G, I selected this one. Then next I selected this one. Then next I can select G to F. If I added this to the set A, it will not form a cycle. So I can do that. Okay. Next, what which I will select? Which I will select? You can note here. This is 4. Okay. This is also 4. Okay. So I can select any of them. Either I can select A to B or C to F. Okay. So here you can note which I selected. A to B I selected and added to the set A. Okay. Very simple concept. While adding it to my set A, it will not form a cycle. Okay. A to B I added, it will not form a cycle. So I can add. Okay. So now these are the things I added. Okay. Next, which I will choose. You can note here. Next, I can choose the next vertex. This I added. Why? Because this is the next edge in the non-decreasing order. Okay. So I selected and added this one. This also will not form a cycle. Okay. Cycle with the selected edges. Okay. Now, next, what I will do, you can note here. Then next, what I will do, I selected 4. Now, which one I will select? Anaga. Which one I will select? I selected 4. Both 4 I selected. Then next one is Anaga.
IG, I6G.
Okay, with the weight 5 or 6, there is no edge with weight 5. Then I will select edge with weight 6. Okay, that is I to G. Okay, but what is the problem? I selected this edge I to G with weight 6. If I selected this one I to G with weight 6, then what will happen? If I added this to our set A, it will form a cycle. Okay, so it is not possible. Okay, this is very important. That is, I will select 6 edge with weight 6, which is I to G. But if I tried to add it to our set, okay, this is our selected edge set A. So if I added this one here, then what will happen? It will form a cycle. Okay, so it is not possible. Okay. Okay. So this arrow mark I given here, but I didn't added it to the set A. Okay. Then what I will do? I will try the next edge with weight 7. Okay. So I selected 7 and added it to my set A. Basically, set A contains selected edges. Edges are adding one by one. Okay, these are shaded and shaded edges. I am showing it. Okay, these are all added to A. Okay, so next what I will do, 8 is there. Okay, 7 is processed. Next is, okay, you can note here one more 7 is here. Okay, next I will select it. Next one, which is 7. Suppose I added this to the graph, then what will happen? It will form a cycle. Okay, it will form a cycle. So it is not possible. So it is not possible. Okay, so it is not possible to add I to H edge. Okay, what I will do next? Now 7 is finished. 8 is there. Yeah, 8. There are 2 8s are there. Okay, now I will ask the question to Devika. Devika present or no? Devika. Devika present അല്ലേ? Okay.
Hello.
Devika next എന്താ ചെയ്യാ?
Next 8 നോക്കൂ.
8, അതായത് 2 8 ഉണ്ടല്ലോ, 2 വെയിറ്റ്, 2 എഡ്ജസിന് 8 വെയിറ്റ് ഉണ്ട്. എനിക്ക് ഏതെങ്കിലും സെലക്ട് ചെയ്യാം. ഓക്കെ, സപ്പോസ് ഞാൻ ഇതാണ് സെലക്ട് ചെയ്തത്. ഓക്കെ, ഞാൻ എന്നിട്ട് എന്ത് ചെയ്യും? ഇതിലോട്ട് ആഡ് ചെയ്യാൻ വേണ്ടി നോക്കും. അതായത് ഈ ഷെയ്ഡഡ് എന്ന് വെച്ചാൽ ബേസിക്കലി സെറ്റ് എ ആണ്. ആ സെറ്റ് എയിലോട്ട് അതിനെ ആഡ് ചെയ്യാൻ നോക്കും. ആഡ് ചെയ്താൽ അത് ലൂപ്പ് ഫോം ചെയ്യുന്നുണ്ടോ ദേവിക? ഇല്ല. സോ ഐ ക്യാൻ ആഡ്. ഓക്കെ, സോ ഐ ആഡഡ്. ഓക്കെ, very simple concept. Okay, 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 thank you Devika. So next what I will do, I will try to select this one. Okay, this one. Okay, so this is also weight 8, but if I selected this, you can note here a loop will come in this way. A loop will come in this way. So it is not possible. I can't select this one. I put arrow mark here, but I can't select. Okay, okay, next what I will do, next after 8 I will select 9. Okay, so there is only one vertex with 9. Okay, so I select it and tried to add it to A. It will not form a cycle. Okay, so I added. Okay, no problem. Okay, okay, I hope you got the idea, and it's a very simple algorithm. Okay, next what I will do, after 9 I will try to add a 10 this edge. Okay, but what is the problem? It will form a cycle. Okay, so I will not add. Okay, okay, so next what I will do, next I will select 11. Okay, so if similarly if I selected and added this one, it will form a loop in this way. So I can't select this one and add it to it. Okay, so this also finished. So now we processed all. Now 14 also remaining. Okay, 14 also remaining. Now if I selected 14, this also constitute a loop. Okay, you can note here, this also forms a loop. So I can't select 14. Okay, so now I processed all the edges in the non-decreasing order. Okay, and added it to the set A. These shaded regions show the set A. These shaded regions show the set A. That is basically the final set A will be the minimum spanning tree. Okay, this is the minimum spanning tree of this graph. Okay, this is KRUSKAL algorithm, and basically it's a very simple algorithm. Okay, in the university exams they will give a graph and will tell to perform or tell to find the minimum spanning tree using KRUSKAL algorithm, and draw each step in the algorithm. Okay, so this is the method. Okay, okay, so this is the algorithm and this is the working. I think, and it is very simple. And here in the algorithm you can note that find set of u not equal to find set of v is used for what? Is used for Sarang. What is the use of this statement? Sarang. What is
No,
the
sir.
use of this? What is the use of this one? Find set function is used to find a particular vertex in the set. Okay. So what is the use of this statement? It is used to check cycle. It is used to check whether the selected edge will form a cycle. Okay. 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 Anyway, this is the algorithm and it's working. So we studied what is MST and okay, Saran, thank you. Next, what is MST? One is Kruskal algorithm and Primus algorithm is there. So what is Kruskal algorithm? This algorithm we discussed. Then we discussed the working of this algorithm. Okay. So basically we should we can imagine in this way also. Okay, so initially A is empty, we will arrange it in the ascending order of the weight, then we will select edges one by one. First I will select this one and add it to A. If it will not form a cycle, then sorry, in this way I will select H to G and check whether it will form a cycle with the previous edges in A. Okay, if it does not form a cycle, then add it to A. Then I will select another, then check whether this edge will form a cycle with the edges in A. If it does not form a cycle, then I can add. In this way, I will take each edge and I will process each edge. Okay. So this is the working of the Kruskal algorithm, and okay, I'll give assignment based on these topics. Okay. Okay. Now we are moving to the next algorithm. Okay. So which is the next algorithm? Which is the next algorithm? That is the Primus algorithm. Okay, Primus algorithm. Okay. So wait. Okay. I think one more hour in today, so we can discuss the Primus algorithm in that class. Okay, so basically I'll just show the Primus algorithm. Anyway, we can discuss this in the next class. Okay, no problem. So this is the algorithm, and we want to study the working of this algorithm. Okay, this is the working of this algorithm. We want to discuss that in the next class. Okay, thank you. Okay,